Today we're going to start a new chapter, Matter and its Changes. So take a moment, write this down. Matter and its changes. So we're going to talk chemistry this chapter. This is something a lot of you guys will be taking in high school, so I think it's a good idea just to have a little bit of background on it in junior high. Okay? If we tore a piece of paper into half until we could no longer tear it into half, we're signifying what matter is. We could take anything, a piece of gold, and cut it in half, and cut it in half, and cut it in half, and we would eventually be left with the simplest form of gold, one single atom. I'd like you to write this down. Atoms. Greek word meaning indivisible, the basic units or building blocks of matter. Atom, a Greek word meaning indivisible, the basic units or building blocks of matter. Last year, with life science, everything was made of cells, okay? Wood, your skin, your hair, things like that, okay? Well, this year, everything's made of atoms. So I could break anything down into simple atoms. The wood on the desk that is made of cells, if I could break it down into carbon atoms. Most living things made of carbon. Anything metal, I could break it down into tin or iron or aluminum or whatever it might be. So you can't break it down any further without losing its properties. I would like you to write this down. Structure of atoms. Atoms are made up of tiny particles called subatomic particles. Atoms are made up of tiny particles called subatomic particles. Basically, atoms are made up of smaller materials. Now you might say, well, an electron is smaller than an atom, but an electron does not act like the substance. So, an atom is the simplest form of a certain type of substance. We have three types. We have protons. Take a moment, write this down. They have a positive charge located in the nucleus. Protons, positive. And a lot of times you'll see them as either a plus sign or a little ball like that yellow one with a plus sign in it. And that signifies a positive proton. Neutrons, also in the nucleus, they have no charge. I think of neutrons as they are neutral. If your car is in neutral, it's not going forward, it's not going backward. It's neither, it has no charge. Neutrons, no charge. These are also located in the nucleus. You'll usually see them as a different color in a graphic. So they'll be right next to the protons, mixed together with the protons. The protons will have a plus on them. The neutrons will usually be a different color. Neutrons, neutral. I guarantee this will be on the test multiple times. The third part there, electrons. Electrons have a negative charge located flying around the nucleus. And they're usually super tiny compared to the protons and neutrons. The protons and neutrons are pretty good size. They're in the nucleus. Electrons are tiny little ball-like things, and a lot of times they'll have a negative on it, a negative sign, or they might just be a negative sign flying around the nucleus. So protons and neutrons are kind of stuck together. Electrons are bouncing around, making an orbit. So you need to know protons, positive in the nucleus, neutrons, neutral in the nucleus, electrons, negative outside of the nucleus. There you go with the diagrams. You'll see the first one, hydrogen, has 1 proton and no neutrons, and it also has 1 electron. So you see the size comparison there. You see that it has a plus sign in the proton, a negative sign in the electron. Helium has 2 protons, 2 neutrons, and 2 electrons. Carbon has 6 of each. So you see how that kind of stacks up. Whoops. Why don't we stop there for today?